Okay, so number 4, f at x is equal to bracket x minus 2 times x plus 2. Now, we can look at it quickly and deduce that it's going to be quadratic, but say you were confused. There were several different factors in this. Yeah. The key to this would just be to FOIL or simplify the question. So when we simplify this question, x times x is our x squared. X times positive 2 is positive 2x, negative 2x, and negative 4. Okay? These two in the middle cancel out, but what's very important is the degree of this polynomial. The degree of the polynomial is an even number. So when they ask us if it's even or odd, we say this is an even polynomial in terms of the question. Okay, so the average rate of change is essentially when you have 2 points on a graph. So say we were to roughly graph this. Okay, so we have our numbers there going across here. Let's say that it's almost like a broken line graph. We're at 3, and then this one's not the easiest to draw, but essentially it gets to 4. Okay, and here we go from 27, so again, broken line, 27, or what we should say is 25, something that's nice to work with. 25, 30, 35, 40, 45. Good, that'll encompass everything. So at 3, we're at 27, which is roughly, say there, 3.01. If we were to go y, what this goes with 1, this would be like 3.5 here, okay? So this would be 3.25 and 3.75. So if we were to take a look at this, 3.25, we don't even come close to it. 3.1 is the closest it gets, and that's about here, and that's at 28. So everything's kind of moving along here, and then all of a sudden we get to 4, and we're at 44, right? So we're looking for average rates of change, okay? So we're going to look for the average rate of change. I guess it's considered instantaneous because of how small of an interval it is between the two x variables. And in terms of, we're essentially looking for what we consider is almost like a slope of the two lines in terms of an average change. So average rate of change is essentially you're taking the coordinates of the first one. So we'll call the very first guy 3 and 25. We'll call that our first coordinate, and we'll call this our second coordinate. Okay, and think of it like we need to find the change in terms of y-axis on top. So we'll call our y2, we'll write the two coordinates again. Coordinate 1 is 3 and 27, and coordinate 2 is at 3.001 and 27.015002. Okay, so these are our two coordinates. We have our x1, y1, x2, and y2. We want to think of this as your average rate of change is equal to your y2 subtract your y1. Very similar to slope, right? Yep. x2 subtract x1. y2 is 27.015002. Subtract our 27 divided by x2 is 3.001, subtract 3, okay? This is going to give us positive 0.015, yeah, that's right, 002, divided by 0.001, and we'll plug that into our calculator to see what we're going to get here. 0.015002 divided by 0.001. 15.002. Okay, so 15.002. This is technically an average rate of change, but because the interval is so small, they're considering it an instantaneous rate. So we found, like I said, sorry, this was an average rate of change, and that's not exactly what they're going for. So the change here from this point, and we'll zoom in a little so it's easier to see. From this point to this point, okay, the rate of change was 15.002 meters a second, right? Mm-hmm. Then from here, I quickly did it on a calculator, we ended up with 15.02 meters a second. To here, we got 15.2 meters a second, okay? And to here, we got 17 meters a second. So what I want us to focus on is I want to focus on this and the pattern it was producing, okay? So we clearly started. This is not technically instantaneous. It is, like I said, average. It's a very very quickly, but it's not exactly instantaneous. So what we were doing is we were clearly coming up from a number, okay? And we don't exactly know what the number is, but what happened is the time interval increased, okay? We kept speeding up more and more and more. So assuming from these numbers, the instantaneous rate of change, so something is, and remember it's estimated, they're not looking for the top number, is we'd be looking for what the starting point would be. And it looks like we slowly went up by 2,000ths, then 200ths, then 2/10ths, and then the number 2 in terms of seconds of speed. So essentially, as we got smaller and smaller, we would technically go 0, 0. Oh, sorry, that's going to make those. We would have technically kept going in this pattern. We would have got 15.00002 and smaller and smaller and smaller until what was the number we would assume we were coming from? Yeah, essentially 15 would be the estimated instantaneous. That would mean there's almost no time passes between those two. So from going from 3, from that very 3-second mark, to the very most possible, the smallest numbers possible, larger than that, which, you know, we can't really represent because there'd be hundreds of zeros in between it. You know, 0, 0, 0, 0, 0, 1, and because numbers are infinite, our estimated instantaneous rate of change would be 15 in this case, because that's the pattern. Yeah, that is a tricky one. Okay, let's say that one more time. So we found all the average rates of change, like we had said before, and then we were to estimate the instantaneous. Okay, so in this one here, they're talking about a difference quotient. We're not quite sure what the question's asking us, so what we're going to do is try to gather a little more information by plugging these values into our function. Okay. So in our first one, we plugged the number 3 into the function, so we're looking at f at 3 is equal to, we get 2 by 3 squared minus 3 by 3 plus 9. This is going to be negative 9 plus 9, those will cancel out. Okay, 3 squared is 9 times 2, 18. Yep. F at 3 is 18. Our other one is f at 3 plus h into this function. Let's see what kind of information this is going to give us. Plus h squared minus 3 times 3 plus h plus 9. Okay. In this one, we're going to have 2 times, and this will give us h squared plus 6h. Does that make sense to you?
I think just 6. Oh no, because
there's an h there, yeah.
Okay.
And the other one we get 9 plus, minus 3h plus 9. We get 2h squared plus 12h plus 18. Minus 9 plus 9 cancel each other out. Minus 3h. We're looking at 2h squared plus 9h plus 18. Okay. So we've plugged those values in. We've gotten 18 as f at 3. The other function here (9). Okay, so instead we're going to try our calculus here. We're going to use the two functions or the two terms that give us 3 and 3 plus h, which essentially satisfies this and our x, right? So we go to put them into the functions. Oh, we've actually already solved this up above, right? We know what these two values are. We know that the value of f at x, or f at 3, is 18. And we know that the value of f at 3 plus h, which is the first one, is 2h squared plus 9h plus 18. So what we can do is we can go straight into plugging those in for these two right here. Okay, does that make sense to you? Mm-hmm. So what we're going to get on top is 2h squared plus 9h plus 18. Subtract. F at 3 was 18, like we said before, divided by h. The 18s cancel each other out. We're left with 2h squared plus 9h divided by h. This h will cancel that one out and take away one of these h's. And that one on the bottom goes. So we're left with 2h plus 9, which is essentially their question, part D. Okay. So when we're talking about these, like a limit of x approaching 0 or a change in y over the change in x, so they describe it like this: limit of a change in x as it approaches 0. Okay, so almost like instantaneous change again. Okay, which is also known as change in y over the change in x, is equal to the limit of h as it approaches 0, which we use this formula for the function of a is the point we're at, plus like instantaneous change here, or whatever our value of h is, subtract the function of our a divided by h. And h is essentially 0 because it's our instantaneous change, okay? So let's say we're dealing with, in this question they've given us, this is the equation of this hyperbola. It is y equals 1 over x. This is our equation, or our function, okay? Yep. So we have our function here, and they want to know, find the tangent line to the hyperbola at point -2 and -1/2. Okay? Here's our x value. So what they're talking about is our function is this right here, 1 over x, and they want to know our a is talking about our x value, okay, the x value at that point. So we'll be plugging those functions in. So essentially your idea then becomes the limit of h as it approaches 0 is the function of a plus h. Our a is, or our x, usually they refer to it as x plus h, but a in this one is -2. So our idea here is 1 over -2 plus h. We've now replaced the x, remember, because this would be our x value, with that, okay? That's the function. We put it into that function. Subtract, the same idea, that function is 1 over, again, the x is just -2 in this one. Okay, so we'll do this one. Here's our a value, here's our a value. In this one we added plus h, and then it is divided by, according to our function, h. Okay, so we divided that by h. So what we need to do now is we need to put these together. We need to work on combining and isolating. So what we have here is we're subtracting. We're going to need a common denominator when going through this. Okay? So think of this. How can we get a common denominator to go through this? And in order to get a common denominator, we're going to probably have to multiply both of them. Well, first of all, we can simplify. We get 1 over -2 plus h. Because this is subtract -1/2, it becomes +1/2 divided by h. Okay? So still the limit of h as it approaches 0. We need a common denominator here, right? So essentially we're going to multiply this function by the denominator on the left, and we're going to multiply this function by the denominator on the right. When we do that, we're going to end up with a common denominator. So on the first one, what we'll get is you'll get 2 over, and we multiply the top and the bottom of it by 2, right? Multiply top and the bottom by 2. And in this one, we multiply the top by -2 plus h, and multiply the bottom by -2 plus h. So we have common denominators here. So we get 2 over -4 plus 2h. Plus, and in this case on top we get -2 plus h over 2 times -2 is -4 plus 2h. So we have a common denominator now, and again this is all divided by h. A lot of math to go into this one. Now because those are common denominators, limit of h as it approaches 0, we can refer to this as just all above. This is all above 2 plus -2 plus h divided by -4 plus 2h, because we know it's a common denominator, we just have to add the numbers on top, right? Which is then divided by the term h. Okay? Now that's getting a little confusing. We have a fraction divided by a fraction. Think of it like this. We're dealing with this divided by h. A fraction divided by the term h here. Okay? So what we're going to do is I'm going to rewrite this. What this also would look like is this would look like 2 plus -2 plus h divided by -4 plus 2h divided by h. Okay? Now this is dividing fractions. I don't know if you remember the rule of dividing fractions.
Can't you cancel out the 2?
On top?
Yeah.
Yeah, they're eventually going to go. But what I want to do first is I'm just going to get rid of our h's. So what happens is we're going to have to invert this fraction and multiply. Okay? So we're going to get the same function here multiplied by 1 over h, which means the h goes to the bottom of this function. So we're going to be left with limit of h as it approaches 0. Yeah, you're right. On top, you're going to get 2, so we get h divided by, and we need negative 4 plus 2h times h, okay, because of when we inverted that function. We're then going to have h divided by negative 4h plus 2h squared. Okay, and we could rewrite that if we like. 0 h divided by 2h squared minus 4h. I can take a greatest common factor out of the bottom. What can I take out of the bottom?
2h.
Yeah. Limit of h as it approaches 0. We take 2h out, so we get h over 2h. We get h minus 2, right? What happens here? Limit of h as it approaches 0. These h's can cancel each other out. This one and this one. So we're left with essentially 1. And this one would be a 1. 2 times 1 is still going to be 2. Okay? So we get the limit of h as it approaches 0 is 1 divided by 2 times h minus 2. Now that we've simplified this enough, we plug in 0 for h. Okay, so we replace h is 0, plug it into here. So we get 1 divided by 2 times 0 minus 2. Is this making sense?
Yep.
Which is going to give us 2 times negative 2, which is negative a quarter. So the limit of h as it approaches 0 is negative a quarter. So we have our function here. Y is equal to the root of x minus 2. This is our point, x value and our y value. Okay. Now we're trying to find tangent to this curve. So the slope of our tangent is going to be equal to the limit as it approaches x, and that is f at x plus h minus f at x divided by h. Okay? So we're replacing our x values with the number 6, essentially, because we're looking at this specific point. So we'll replace x with 6 in this question. So our functions then become limit of h as it approaches 0. Function is the root of, and we get 6 plus h minus 2. Subtract the root of 6 minus 2, all divided by h. Okay? Limit of h as approaches 0. On the outside, we're going to get 6 subtract 2 is 4. Root of 4 is 2, right? So subtract 2. In the other bracket, we're going to get 6 minus 2, so we get root of 4 plus h. And then all subtracted by 2 divided by h. This makes sense? Okay. Yeah, so this is where you're right. We have to multiply by the conjugate. So what we do here now, we multiply by root of 4 plus h plus 2 and 4 plus h plus 2. Whatever you do to the top, you got to do to the bottom. Okay? So when we multiply through this, think of this almost like it's a FOIL again, right? We have this and this, and we have this multiplied by this. We're multiplying fractions. That's the idea here, right? So I'm going to do this the long way. In the book, they've shortened it, but I'm going to show you the whole process, okay? So our first terms are root 4 plus h times root 4 plus h. Do you know what that's going to leave us with?
4 plus h.
4 plus h, good. So we get 4 plus h, okay? Then, our outside terms, think of this, 4 plus h times positive 2. That's going to give us what? 2 times root 4 plus h. Okay? Not much we can do because we can't root that number, right? And our inside terms, a negative 2 times 4 plus h, well, that's going to give us a negative 2 root 4 plus h. The idea of that, the whole reason we multiplied there is so we can cancel those. And finally, our last terms, negative 2 times positive 2 gives us negative 4. Okay? Divided by. And then this one, we distributive property, we're going to get h times root 4 plus h plus 2h. Up here on top, these middle terms, positive 2 times 4 plus h and minus 2 times root 4 plus h cancel each other out. Okay? So we have limit of h as it approaches 0, and we get 4 plus h minus 4. Okay? And here we have, here we can factor something out of both of these terms. Okay? We can take a greatest common factor out of this here. What can we take out of both? H, yeah. We didn't have to distribute it. We could have just left it the way it was before. So times 4 plus root h plus 2. Okay? On top, our 4's cancel out. So we have h over h times root 4 plus h plus 2. Limit of h is approaching 0. H's cancel out. We're left with limit of h as it approaches 0, 1 divided by root 4 plus h plus 2. Okay. From here, we're going to plug in our value of h. Our value of h this whole time has been h at 0. H is 0. So when h is 0, we get 1 over root 4 plus 2. Well, I wrote root 2 because it's the answer, but root 4 plus 2. Limit of h as it approaches 0, which is 2 plus 2. So the limit of h at that, when x is 6, as it approaches 0, is 1 over 4. Okay, so this question states, question says, if sine theta is equal to negative root 3 over 2, remember, sine theta is essentially opposite over hypotenuse, right? Mm-hmm. Essentially, what are the possible values of cos theta and tan theta given these certain things? Those are the possible answers. So what are the possibilities of cos and tan theta? So first of all, we have to figure out which special triangle they're talking about. Obviously, they're talking about this triangle here, right? So let's superimpose, or let's bring it over. Oh, it's all written like that. Let's redraw it over here then. So our special triangle, in this case, we'll get all our information down, is we know that if this is our root 3, this is 2, this is 1, we'll call this 60 degrees. This is our 30 degrees, also known as pi over 6 for in radians, or pi over 3. Okay, is that information? If we're dealing with negative, so sine is opposite over hypotenuse. So we're talking about opposite over hypotenuse. Opposite side will have to be the root 3. So we're talking about our 60 degrees, right? Mm-hmm. So we're talking about sine 60. Sine 60 is equal to, and now it's a negative root 3 over 2. So we got to think of our cast system. Okay. So we're up here in our cast system, cosine, all of them, sine, tangent. So right now we're either in the third or fourth quadrant are possible answers to this. Okay, we're in the third or fourth quadrant because sine is negative in there, which means we're dealing with, again, it was, what did we say it was? Opposite over hypotenuse. So let's try and draw up something here. We're in our fourth quadrant, so I'll kind of draw it like that. We're talking about this as our angle. These are our triangles here. We know they were 60 degrees, we were saying, right? We're talking about the 60-degree angle and the 60-degree angle. If we're making triangles out of these two here, that would give us, this distance is root 3, this distance is root 3, this is 2, and the other distance is 1. What are our options dealing with this specific angle here? What are the possibilities of cos and tan? Okay, so in the first one, again, we're talking about tangent being positive and cosine being positive. So our options here is we have cos 60 is adjacent over hypotenuse. So we're talking about, in this one, cos theta would be adjacent is root 3. Hypotenuse is, oh, we're doing opposite over hypotenuse, right? Oh, I drew those triangles a little wrong, because those are the adjacent side. Though the root 3 should have been the opposite side. Okay, did I draw those? Yeah, that should have been 30 degrees if that's 60. My fault. I did make a mistake here. These two are mixed up. Okay, this should be root 3. This should be 1 root 3. Okay, so then what that means is the adjacent is 1 over 2 in terms of cos. Does this make sense to you?
Yep.
Okay, so we get 1 over 2. Cos could be 1 over 2. And in this quadrant, it would be negative. Okay, in this quadrant, it would be cos theta 1 over 2 is positive, because cos is positive. And this one, tangent is equal to opposite over adjacent, so it's root 3, or tangent is equal to negative root 3. Okay? So we technically have 4 options here because of what quadrants we're in, but do they talk about that in these ones? Oh, they just give you specific options. So option A is positive cos is a half and negative root 3. That's a possibility. Cos being negative a half, tan being negative a half. No, that wouldn't be in the right quadrant in terms of what we're talking about. So the first one was okay, checked out, because we had a positive cos and a negative tan. They then said negative cos and negative tan, that's not the same quadrant. We're not talking about the same triangle. Okay. Negative cos being a negative half and negative root 1 over 3, not even the same triangle. And negative half and 1 over root 3, not a possible answer too. So we're looking for number 1. They were talking about being in the 4th quadrant. Okay, so we're talking about 4th quadrant here, where cos is positive 1/2 and tangent is negative root 3. So we're talking about question A.